Hello everyone, this is Mohammed. I am here for the new tutorial on how to make a smooth three-dimensional surfaces with a procedural meshing in Unity game engine for using in the virtual and augmented reality project. This is very important topic, and let's start. So if you look at this object in the Unity, and if you look at the mesh here, the mesh is the combination of some triangles near to each other. And in fact, this is the most important things in the meshing. We have triangles, and each triangle has nodes here and has the edges here. So in order to define a mesh here, three-dimensional surface mesh, definitely we should define triangles, and we should put these triangles near to each other. This is the most important rule here. So, and if you click on a sphere here, and if you look at the features of this sphere, you can see we have a mesh filter and we have a mesh renderer. Mesh renderer is related to material and something else, but mesh filter is the main part of the mesh. Mesh filter, if you look at the mesh filter, and if you click on here, and you can see in fact the pure mesh. This is the combination of triangles near to each other. You can see, you cannot see any material or something. And these meshes, for example, has more than 500 vertices and more than 700 triangles near to each other. And this is a sphere. So in order to define our favorite mesh, surface mesh, so we should define the triangles and vertices for it. First of all, so let's start. First of all, I will delete this mesh. We don't need the sphere. And I will go to game object, click empty game object, and I define the, for example, 3D mesh. This is just a game object, and as this game object doesn't have any mesh filter, mesh renderer, and material, nothing, you cannot see it here. So I just make a position to 0, 0, 0. So here. So I should, assign a mesh filter, assign a mesh renderer to this, to see this. If I click on add component, because mesh filter and mesh renderer are just component, and write mesh filter, you can see it here, and assign a mesh render. So right now we have a mesh filter. This is the very important part of the mesh, and this is just pure mesh. And we have a mesh renderer. Mesh renderer is just about material, shading, and something more. So we should work on this part, especially this part, mesh filter, and we should define a surface, and we should change the mesh filter here by the code. So as a matter of fact, I have written a code, and before explaining the code, I want to one time test the code here. I assign the code. I want to assign a code to this object here. Just assign it here. And right now, if I click on this, go to the scene, I can see our object here. This is our object. And if you look at the mesh filter here, the mesh filter is not none. It is now 3D mesh. Exactly the name we have here. This is the mesh filter here. And if you click on a mesh filter here and just rotate the triangles here, you can see the triangles here. This is a pure mesh. This is 3 vertices and 1 triangle mesh. The meshes of this object. So, and you cannot see the mesh in this side, because these are something related to normals on the mesh, and I don't want to speak about it in this tutorial. Just rotate it to see it. So this game object is right now pink because we do not assign any material to this. We can assign a material. If again I click on play, so, and again click on 3D mesh, as you can see again the mesh filter is none. So why the mesh filter is none? Because our code has written in the start, void start, and when you click on a play, the mesh will be defined based on the code. I will explain it more in the code. And just we can fill the material right now. Just in the project, we should right click and we should create folder material. Easy, and just click on the material. You can right click, create material. You can say material, for example, 1, any name you want. Just click on this, and we have a maps here. Just click on here. You can, for example, design, for example, this color, red color. And for assigning a color to this object, you can assign it by this of a material here. And if you look at the in the mesh renderer, if you look at the material, now it is not none, it is material 1, exactly this material. And again, if I run the code, our material is red, it's not pink. So let's start to explaining the code. But before explaining the code, I want to tell you two important things. First of all, for defining the surfaces, I assign a code directly to this game object, the 3D mesh, which will be our surface at the end. And we assign a code exactly to this code, because we want to fill the mesh here in the mesh filter component. We want to fill this part with the code, so we should assign a code exactly to this game object to fill the mesh part of this game object. And number two, if you look at this word, for defining the mesh, we have two important things. One is vertices and one is triangles. If you look at the nodes here, we have node number 0, node number 1, and node number 2, and each node has a positions. So the position of the nodes is vertices. We call it as a vertices in the code, and it's very important. And so for this reason, the vertices is vector 3 Ri. It means that the Ri, which includes the position of the nodes near to each other. And in order to define triangles, you should first define a vertices, and after that you should say the order of the vertices based on that, and they should be clockwise. For example, here the order will be number 0, 1, 2. So for the unity, I should define two important things. One, the vertices, which is the position of the nodes, 0, 0, 0, 0, 0, 1, and 1, 0, 0, the position of the node. And the triangles, which is the order of the nodes, 0, 1, 2. In fact, this 0 here is referred to this position, and this 1 here is referred to this position, and this 2 here is referred to this position here. So we should first define a position of the nodes, and second we should define the order of the nodes, which should be near to each other. And these two things are very important. And both of these triangles and vertices are the component of the mesh, as we will see in the code. So let's go to the code. So now let's start speaking about the code. Very exciting part. As you can see in the update function, we don't have any things, and in the just I have written everything in the start function. For this reason, when you click on play, you can see the mesh. Otherwise you cannot see the mesh, because I have written everything in the start function. And it's very easy code. And before starting, I have written I have defined, in fact, something here, and these are very important. I have used many H and many S here, because I want to tell you that these are just names and you can change it very easily. So it's not important, these are just names. I have defined mesh with the many H, and this mesh is the member of the mesh family, or mesh class, in fact. What does it mean? It means that our mesh with the many edge near to each other can have the features like other meshes. So what are the features of like other meshes? Can have triangles and can have vertices. So this mesh, so we should just define triangles and vertices for this mesh with the many edge. When I define it as a member of this mesh here, I can now define triangles and I can now define vertices for this mesh. Without defining this mesh as a member of this class, vertices and triangles do not have any meaning. So right now we can define vertices and triangles. I have defined vertices, and based on our word here, vertices are just the positions of the nodes. So we should define a vector 3 Ri. It means that we have a Ri which includes some vector 3 near to each other. For this reason, I have used vector 3 Ri vertices, and I used int Ri triangles. What is this? What the meaning of int Ri? It means that I have Ri and it's included some integer number like 0, 1, 2, 3, 4, 5, 6, 7. And I just name it as a triangles. So this is our triangle 0, 1, 2. So this is integer Ri and this is vector 3 Ri. First of all, here before starting anything, we should define them. And we should specify what are there exactly, and in the start function we should fill this things in the start function. So meshes, what was the mesh? Meshes was a member of the class of big mesh. So now we should fill this mesh. How can we fill it? With this line code, I'm saying that this get component mesh filter mesh. This, it means that this game object. What is the game object? If we look at this game object, which we assign a code to this, we assign a simple 3D mesh code to this game object, 3D mesh. So this will be this word here, this will be this game object, 3D mesh. So okay, this game object. So what after this game object get component mesh filter? It means that get the component of mesh filter of this. So if we look at this game object, there is a component and which name is mesh filter, and we are now in the code we say, hey, get the component of this mesh filter. So what is the component of this mesh filter is the mesh. If you look at here, we say get component mesh filter mesh. It means that get the mesh component of the mesh filter of this game object. Yeah, get the mesh features of the mesh filter component of this game object. It means that go to the code and get this exactly this, because we want to fill this part. So first of all, we should call this part, and after that we should fill it. Okay, you can call other parts too, but now for making a 3D mesh, we should call this part. So now our meshes is specified. So we should define a vertices. What was the vertices? Vertices was the position of the nodes. And first of all, we say vertices could be new vector 3, Ri 3, in 3 inside. It means that we have a Ri and we have a 3 position inside, but the positions are not specified. But we know that there is a Ri and we can define the 3 position inside this Ri. And I have defined triangles, again new int Ri. It means that triangles are new, and we have Ri, and we know that this Ri can have 3 integer numbers, but we do not know what are these 3 objects. So these are just the size of this Ri, these 3 numbers here. Pay attention. these are just the size. So now we will fill them. So vector 3, the vertices Ri 0, it means that go to these vertices, and the first component of these vertices is new vector series 0, 0, 0. It means that exactly this part. Now we are defining this part. This is the 0, this is 1, and this is 2. If you look, for example, 1 is 0, 0, 1. Exactly here, 0, 0, 1. And if you come back here, vertices 2 is 1, 0, 0. It means that this, position is 1, 0, 0. Exactly like we have here. I'm just filling the vertices that we define. And exactly like this procedure for triangles. Triangles 0, triangles 1, and triangles 2. It means that this. So what should be them? They should be 0, 1, 2. 0, 1, 2. These are just this, the index. Please don't confuse between these and these. And vertices with the index 0 should be this. Vertices with the index 1 should be this. Vertices with the index 2 should be this. So right now our vertices and triangles are specified. Our meshes is just, we told it to get this part of the mesh. So we should right now fill this part. How? As the meshes, pay attention, as the meshes is the member of the big mesh here, this class. So this meshes has a vertices feature and triangles features. And these two components on these two features are just because this mesh is the one member of the big mesh family. So we should just fill this meshes.vertices. It means that this mesh, vertices of this mesh should be the vertices as we defined here. Vertices index 0, vertices index 1, and vertices 2. And we are telling the code, in the code that meshes.triangles, the triangles of these meshes, these are very important, should be exactly like triangles as we defined here. Triangles number 0, triangles index 1, and triangles index 0, triangles index 1, and triangles index 2. And we define them here. We define the position and we define the triangle. Right now we define the meshes here, and we fill the triangles and vertices of these meshes here. And just everything right now is okay. Just if you save it, you can see the meshes is here. So now in order to add more vertices, exactly like here, for example, I added the node 3 here. Yeah, now we have 4 nodes, 0, 1, 2, 3, and this triangles is added, and we have a new position. So as we have a new position, our vertices, which is vector 3 Ri, we have a new member here, 1, 0, 1 here, and in the triangles we have one triangles here which is 0, 1, 2, and for these triangles we should have a new triangle which will be 2, 1, 3, and I have written all of them in one integer Ri. 0, 1, 2, this part is just for this triangle, and 2, 1, 3 is for this triangle. And this is our triangle and this is our vertices. So the size of our triangles is now 6 instead of 3, and the size of vertices is now 4 instead of 3. So in the code, first of all, the size of triangles will be 6. The size of vertices will be 4. And in the vertices, we have a new vertices, and vertices here 3 as we have here, these vertices, and the position is 0, 1, 0, 1 equal to new equal to new vector 3, 1 0 1, and put a semicolon there. So the vertices is good. So in the triangles, we have three more integers. So I should have for example, triangles number 3, index 3 equal to as we have here 2, and triangles 4 equal to, look here, 1, this triangle, 2 1 3, and triangles 5 equal to 3. Why? Because 2 1 3. You can see the last one is 3. So everything is well. We added one new vertices, and we have 3 more integers in the triangles. So let's start to see. If I run the code here and go to the scene, so this is 2 triangles near to each other, and it's very nice, very beautiful. So we can continue this, just adding the triangles, and in fact vertices triangles. Now I'm going to speak about this surface, Bezier surface, in the Unity game engine, which is the main part of our tutorial. This Bezier surface has some control points, some main control points, as you can see, and there are 1 2 3 4 5 points in each row. Find points here, find red points here, and find yellow points that side. And so we have about 15 control points, and with these 15 control points we can have a control on a surface just with the changing of the position of these control points. Look here, and you can do this with the other control points too. For example, changing these control points or others, for example. So if we look at the surface, we can see many triangles here, and this is exactly the procedural meshing. In the procedural meshing, we define many triangles near to each other to define a surface, and each triangle has nodes 1 2 3, 1 2 3, and these nodes are near to each other. And we should, for defining this surface, we should define these nodes, the position of these nodes, and after that we can just use a procedural meshing. So we should define the position of these nodes based on the control points here, and here, and based on the all control points we have. So in order to defining the position of these nodes of the triangles, and using the control points, we just using the Bezier curve equations. As I have spoken about it before, there is a formulation here. If you just search a Bezier curve on Google, you can find this equation, and this equation, with these equations we can find the position of each point. And I have spoken about it before. We have defined a function. For example, here the name is calcurve, and in this function we have the input t, and the input the position of the control point, and at the end, as a result, we will get the position of each point here. So we should assign the position of these control points to that code, to this function, to this function, and after that we will find the position of each node here on this curve, not on this surface. So the general thing is that if I use these control points, the green control points, and use that in the Bezier, formulation, or as I have it in the C# here, cal curve function, if I use the position of the green points here, I will have the position of these nodes here. So if I put the red points positions, the red control points position on these equations, I will understand the position of these points here. And if I use this, yellow control point, the position of this yellow control point, I will have the position of this point, this point, this point, this point. I will have the position of the curve, the points, very small points on the curve. So after that, if I have the positions on this curve, for example, this point, so I have the position of the similar like this point in here in the middle, and I have the position of this exactly similar here in this part here, for example. So now I have one point here, one point here, and one point here, and these points are very similar to each other. Just if I use this point again in this function in the cal curve, so I can find the position of this point, this point, this point, and this point, this point, this point, this point, this point in the middle. For example, if I consider the number, for example, here right now we have about 15 point here and 15 point here, but I can change it here. If I just change it, for example, I can make it as a 10, and I can make it as a this way, again as a 10. Look at this here. We have just 10 points here, exactly like a Bezier curves, and this is our U direction in the surface, this direction, and this direction is the V direction. So we have a U direction, and this is the parametric modeling. With the parametric based modeling, we can define a direction based on our favorite direction. This is our favorite direction, this line here, and this is the U direction, and this is the V direction. So we have a different V direction for each line here, and we have a different U direction. It's not important. We can have many U and V direction. This is in fact the parametric based modeling. In the parametric based modeling, we do not have a constant direction. Here we have our own direction, and this is U direction and this is V direction. It's very important. And so when I have read, and in this part, the numbers in the V direction, numbers in the U direction, in fact, these are the numbers of the points in the U direction. For example, if I want to use, for example, 5 point here, number of the points here is now 1, 2, 3, 4, 5 here. So if we use the lowest number of numbers in the U direction, our model will not be very smooth. But this is just for the tutorial, and I want to show you what what is exactly the concept. So if you look at here, and if I put the position of this point, this point, this point, this green point, and this green point on this curve here, and this cal curve equation here, I can find the position of this point, this point, this point, and all of these small points here in this curve. And exactly the similar here for the control points of the red points here, we will understand the position of this line, and exactly like this for the red yellow points. If I use the position of this control point, this control point, this control point, this control point, and this control point, I can understand the position of this point, this point, this point, this point, and this point. So after that, Assume that we understand the position of this point here, and we understand the position of this point here, and we understand the position of this point here. And again, if we use this point here, this point here, and this point here, if we use them in this equation, we can calculate the position of this point, this point, this point, this point, this point, this point. And just with this, method, we can calculate the position of this point, this point, this point, all of the points. For example, for this line in the middle, we just put the position of this point, and this point in this equation. This is the general idea, and now we can have, the position of all of these nodes with this technique. This is the general idea, and I have written it in the code, and now I want to speak about it with the code. And before going to the code, let's increase the numbers, for example, to 20 in the U direction. So now I have a 20 point in the U direction. This is in fact the number of t in these equations. The number of the t here is 20, for example, the U direction, and the V direction in this line is, for example, 10. I can make it to 30, for example, and you can see the surface is very smoother. Yeah. So we just use one equation and we just use it in the Unity. Yeah, and we just use it different control points on these equations. This is the main concept. So before going to the code, I want to speak about this Unity project. Look here. We have 15 control points, and I have defined it, before here. First of all, I have defined the mother points or mother control points. This is the empty game object, and in this empty game object, I have defined the spheres by game object, and here exactly like in the Bezier curve, and all of these game objects, all of these points are the child of these mother points. It's very important. So, and we can access to the position of all of these control points very easy, just as we have in the Bezier curve, and we can call them through the code very easy. So, and after that, I have a Bezier surface object here. I have defined a mesh filter for that. I have defined a mesh renderer. I assigned this code, surface code, to this object, and I've designed a material. And in this, when I designed this, code, our main code to the Bezier surface, to this game object, we need to input two important, numbers, and these numbers are the number of the t in the U and V direction. And what is the U direction? The U direction is, in fact, this direction in each line, this direction, and the V direction is this direction. Please don't, do not think that U and V are the same as X and Y or X and Z. No. The X and Y and Z are the constant, direction, but the U and V are our favorite direction. When I change the position of these points here, our U direction is here. Our U direction is this, and our V direction is this. When I change the position here, our V direction is this, and this flexible direction, not constant direction, these flexible directions makes the whole procedure very, very nice, because you have more control. So we can change the numbers here to 20 and 20t in this direction, 20t in this direction, and we need to input mother control points is exactly this. We should just input it, and we just have other things. We just have a code. Let's go to the surface code here. So I have it here. Let it do. So in the code, this is exactly like a Bezier code, Bezier curve code, and very easy. Do not worry. Everything is based on the one equation. First of all, I have defined a mother control points. Mother control points is this. I want to speak about some of them very fast because we had it before in the Bezier curve too. So mother points here. We just use these mother control points to grab the position of the each control point as a child of this mother. And we have a control point position list. Yeah, as we had it in the Bezier curve, I have spoken about it before. And we have a list surface point position. It means that this is a list, and this is a list vector 3. It means that it's a list that's and many vertices are included inside. And what is this? The surface point positions. It means that if I run it, you can see. If I run it, these are the position of these points, these points, these points, these points, these points, the position of all of these points. And as this list vector 3 surface point position is public, so definitely we can see it here. If we go here, surface point position. If you click on this, here, these are the position of all of these points. You can see 0 and 35, 36. These are the position of all of these points. Why we can see it? Because we have written it as a public. So again, we have a mesh because we want to define a mesh, and the mesh is in the member of class of mesh. So our mesh should have a vertices and triangles, as I have spoken about it before. And we have a vertices, again, vector 3 Ri, the vertices. And this part is just for procedural meshing. We have triangles. We have number in the v direction and number in the u direction. These are the number of t in the u and v direction, as we have it in the Bezier curve formulation, the number of t. So in the void start, we just grab this mesh, as I've spoken about it before, and we had it before. I just grab this mesh. Well, so what is the mesh here? In the code, in the Bezier surface, I assign this code to the object Bezier surface. I assign it here. You can see the code here. So the code should grab this mesh filter here and should make changes on the mesh here. Right now it is none, but after playing, this is not none. If you look at the Bezier surface mesh filter, this is the Bezier surface. So this is because we grab it at first in the code. Here in the start function, we grab this mesh from mesh filter and we just do something on this mesh. And so for this reason, you will see the final result as a Bezier surface. And if you just click on it, you can see the whole, surface here. This is exactly this surface. So how many vertices? For example, here we have 2,500 vertices and more than 4,000, triangles. And we have here, very nice, very beautiful. So let's continue the code. So in the void update, I have written some nice, function here, and everything will be here, the points. Number 1, making list of points. This is very easy. Just this will grab the position of each control point from the mother and calculate the surf point and make a mesh. This is the 3 step, and everything will be done in the update function. So if you change the position of one control point, everything will be calculated again, and then everything will be updated again. So let's start making the list of points here in this function. What will happen? We have this list, control point position. This is one list here, and we just write as a new list. It means that, hey, make it new. Each time make it new. And so for int I4, I equal to 0 and I equal to mother control points that child count. It means that for these points here to here, about 15 points, just do one thing. What? Add the mother control point, get a child, the I dot position, and add it to this list, control point position. Yeah, as we want it. It means that all of these points it means that the code should get the position of all of these control points and add them to the list, and our list will be full after that. So, and each time because this function is in the update function, each time this procedure will be repeated. So the list will be empty with the new function, and the list will be filled. The list will be empty, the list will be filled. For this reason, when you change the one point position, everything will be changed, because the list will be empty with this line, new list, and this list will be empty, and after that this list will be filled with a new control position. So when you change the position of even one child, even one point here, this control point position will be changed. So after that, I have defined the cal curve. Cal curve is exactly, we had it before, and this is just this formulation, the Bezier curve formulation here. I have spoken about it before, so now, right now, it's no need to speak about it again. This is just need the position of control points and t here. If you use the cal curve, the cal curve function, you can change the name as you want. So if you just put these positions, the green control point position to the cal curve, you can understand the position of each node here. For example, these 50 points here, and if you put these control points, this green, this red, this yellow, you can understand the position of each point here. Very easy. And if you use, it's very easy. So, and I should use this function many times. So this cal curve is just for defining the Bezier curve equations. And after that, now I want to speak about this function cal surface 2. Cal surface 2 at first will get the positions of all control points. And what does it mean? All main control points. In fact, this point, this point, this point, this point, this point. And we have 5 here, and we have 5 at the end. At first, the cal surface 2 will get the position of all these 15 control points, and will divide these control points to the 3 part. Part number 1, part number 2, and part number 3. Part number 1 is the positions of these points, these green points. Part number 2 is the position of these red control points, and part number 3 is the positions of these yellow control points. How it is possible? When I wanted to make the control points, first I make these 5 control points, and after I make these red control points, and after I make these yellow control points. If you see here, and if I click on this is the first control point, second control point, third, fourth, and and this is the number 5. So, and after that, number 6 will be this. 7, 8, 9, 10. You can see. And after that, I have defined the last part. So for this reason, so here in the code, I have defined the 3 new lists here, and in each new list, part 1, part 2, and part 3, just get the position of each group. For example, part number 1 is just the position of these points, part number 4 is just the position of these control points, and part number 3 is just the position of these control points. How is this possible? At first, we get the position of all control points, in the code. And here, if I write this for loop, I can say, so part the points, part 1, the position of the green points, are just the position of the first 5 points of this control points. The first 5 points is these points. If we consider the I as a 0, parts 1 dot add, it means that something should be added to this list, what should be added? The point position, it means that the position of the I0, it means that this point. Because this exactly the position of this point, because point pose itself is the position of the all control points. Yeah, so number 0 will be the first one, and if Ri is 0 and I plus 5, it means that number 5 should be added to part 2 and number 10 should be added to the part 3. What does it mean? It means that the code will do exactly like this. First try to find number 0 this, and number 5 this, and number after that number 10 this. These are the first one, and added to the point part 1, point part 2, and point part 3. And the code will repeat this exactly to the other point. For example, if I is 2, if I is 1, point number 1 will be added to the, again, list 1. Point number 6 will be added to the list 2, and point number 11 will be added to the part 3. What does it mean? Point number 1, this should be added to the part 1. This point, which is number 6, will be added to the part 2, and this point, which is 11, should be added to the part number 3. And just repeat this to the all control points. So at the end, we will have the list of the positioner of this control point as a part 1, the positions of this control points, the red control point, as a part 2, and we have the position of all yellow points as a part 3. So now if we have, for example, 4 rows, we should do it again with we should have a 4 list. If you have a 5 rows, we should have a 5 list. Pay attention to this. So we should define, for example, 2 more, for example, list here, and we should do it again if you have a 5 rows. So just before continuing, I want to tell you one important thing. In the function we have defined here, cal curve, this is for the Bezier curve. We have 2 input, t and the positions of the control points. The t here can has index, can has a value. In fact, in the function, cal curve function, or the Bezier curve function, the value of this t should be used. The value should be between 0 to 1. So this t can has a index 2, because we can have many t in the u or v direction, and for example we can have a 50 t in u direction, 50 t in the v direction, or other numbers. So the t because the t should be between 0 to 1, the t which should be used for the cal curve function or the Bezier curve function will be the index of the t, for example, is 1, 2, 3, 4, divided to the number of t in the u or v function. But in the future, in order to make it very simple, I will say, for example, u is 1, u is 2, u is 3. For example, we have cal curve function, and in the cal curve function, for example, I will say u is 1 or u is 2 or u is 3. But it means that 1 divided to number of t in the u direction, or 2 divided to number of t in the u direction. For example, we have a cal curve and we are using v. For example, I would say the v is equal to 5. 5, it means that 5 divided to number of t in the v direction. Okay, but now the very exciting part is here. Just listen. It's very important, and here we will calculate the positions of all points here, of all points. Very easy, just listen and pay attention. It's very easy. Now we want to calculate the position of all points. So, in order to calculate the position of all points here, just first I want to decrease the numbers. For example, the number of t in u direction and the v direction to 10, and this is, for example, 10, or this is, for example, 6. Look here. So we have a 6 node in the V direction and 10 nodes in the U direction. So first I have defined a list vector 3 all points positions. So this is a list, and it will have the position of all points here, all points, which is very needed. In fact, the positions of all nodes. In fact, so how it is possible? So at first we say that all point position, this is a list, and this list is ready to be filled. We say that this list dot add, it means that add to the list. So what should be added to the list? We say that use the calcurve function, we had defined it before, and use U and point parts 1. So in the calcurve function, what's this function? This is a Bezier function. If in the Bezier function we use the points part 1, if it means that these green points, and we can consider U. U is exactly like a T in the Bezier curve. We have U here, and the number of U's here are 10, because we have 10 here. For example, if we consider U as a 1, and if we consider points part 1, the calcurve U and points part 1, what is it? This is exactly the positions of this U. This is U1, and we are using these control points. So this will be the position of these points. If we use U2 here, for example, U2 and points part 1, it will be the position of exactly this point. If we use U3, this will be the position of this point. If we use U4, this will be the position of this point. If we use U5, for example, until end. So if we use the U1, for example, and point part 1, and we say, hey, the position of this should be added to the all points. And after that, so it means that, for example, this point should be added to the all point. And after that, again, U1 and point parts 2 should be added to all points. What does it mean? It means that for example, for these red points, the U1, it means this line is for U1. In fact, for example, the position of this point here, should be added to the all points. And again, U1 and point part 3 calcurve. What is this? This is exactly the positions of this point here, this point here. So now with the U1, all of the main position of this point, and this point is now calculated, and this is now added to the all points. So what will happen after? In the after, we say, hey, all points, again, we should use the Bezier curve, function, and added these 3 points as a control points. These 3 points, this point, and this point. If we use them as a control point, and we say in the Bezier curve formulation, these are exactly the same function, and consider V. V is the number of T in this direction. For example, V number 2. If we consider V as a 2, so what will we have? So what does it mean? V2, it means that V0, V1, V2, V2 is here, and in this line we had the control points, this point, and this point, V2. This will be exactly this point position. So now we gradually can find the position of all points. For example, if we consider the V, here as a 1, the V will be 0, 1. 1 will be here. And if we consider the U as a 1 here, the position will be this point. If we consider the U as a, for example, 2, or U as a, for example, 3, and V as a 1, this will be this point position. If we consider the U as a, for example, 0, and v as a 1, this will be this position. If we consider the u as a 1, 0, 1, 2, 3, 4, for example 5, and v as a 2, this will be this point position. So now in this function, we should just input a specific u, a specific v, and all the positions of all control points. And what we'll have at the end, what will be the return of this function? The positions of all points. So in order to inputting the specific u and v, many because we have many u and many v. For example, in this example, if you have 10u and 6v, here in this function, so I am using the main function here, calcurve serve point 3 function, and in this calcurve serve point 3 function, I am using 2 4 1 4 is just for calculation of this for u in this part. For example, 1 4 is just considering u 0 1 2 and 1 4 for this v, for example 1 2 3 4 this is very important. We have 2 4 inside to each other for covering all of control points. And here, exactly like in the Bezier curve, I am using cal surface 2 function, this function here, and I'm just using it in 2 4 function, and I'm using all of the control points and u and v as we have defined it here. And finally, surface point position, it means that all of the point positions will be calculated very easy. This is the list we have here, and this list each time will be new and be filled. Each time will be new and will be filled. Why? Because this function is in the update function. For this reason, everything in this function will be calculated again and again. If you look at this code here, everything will be new here. This function will be new and will be filled. So after calculation, all of these control points, for example, 10, for example, 30, number in the v direction 30. Very nice surface, huh? And after that, so we know that the position of all these points right now, so we should just, exactly like defining the one triangle, we should just define all of these triangles. First of all, we should so here in the make a mesh function, I have defined everything for just making the triangles meshes. We have make a procedural grid function. I have written it here. So right now I want to speak about this code here. We have vertices and triangles exactly if we had it before. For example, if you had two triangles, we have vertices and triangles. In the vertices, it's just the position of the nodes, and triangles is just the order of the nodes. And for two triangle here, two physical triangle here, 1 and 2, we have 6 numbers. So and for these two triangles we have 4 points. So the vertices is just the position of these points, and in the here, for example, we know the position of these points, and because in the code everything is calculated before as a surface point position. Surface point positions is the position of these points. Yeah. So how many points we have? For example, here we have 20 points. 1, 2, 3, 4, and 1, 2, 3, 4, 5. 5 multiplied 4 will be 20. Exactly the multiple number in u direction and number in the v direction. So Vertices, first of all, should be defined. Is a new vector 3 array, and in this vector 3 array we should first of all when we are writing new, it means that this is new, we should write the size of the vertices. Size, it means that how many vector 3 will be in this array, how many, it will be the multiple of u numbers in the v direction multiplied in the number in the u direction. It's very big. For example, in this example, the vertices should have 20 positions for the vector 3 in this example here. Just very easy, basically. And after defining the vertices, right now this is defined, and we are now, this is vector 3 array, but the positions are not filled. Here it's very easy with the surface point position as we had it before, and this is the position of all points. The positions of are all points, all of these points. We can use this in the code. We can just say, hey, for I is equal to 0, vertices index 0 should be the surface point position 0. Vertices 1 should be the surface point position 1. Exactly, we just fill this surface point position to the vertices. We just use this for filling the vertices, and this is true. So vertices is now calculated, and this is very easy. Triangle. What is the triangles? If we look at the triangles here, triangles is the orders. And first of all, we should define the size of the triangles. How can I define it? I have defined it before based on one algorithm. This is very easy algorithm. And I just say that number in the v direction minus 1, multiple 2, multiple 3, multiple number in the u direction minus 1. For example, first of all, what does this mean? In fact, if we have two triangles, two physical triangles, we should have six numbers here. So for each two triangles, so we should multiply the number of triangles to 3. We should look here. For example, in this example, how many triangles we have? In this example, we have 24 triangles, 24 physical triangles. Like here, we have 2 triangles here. So the size of the triangles, the size of the numbers in triangles function will be 3 multiple, in this example 2, and in our example 3 multiple 24, because we have 24 triangles here, and the number of numbers in the triangles will be 3 multiple 24. So if we come back here, number in the v direction here is just 5, and 5 minus 1 is 4, 4 multiple 2 will be 8, 8 multiple 3 will be 24, and 24 multiple number in u direction minus 1. What is the numbers in the u direction is 4. So this will be 24 multiple 3, exactly what we have, what we know it before. Right now, the triangles, exactly like vertices, is now new here. It means that we just define an array, and we just say, hey, this array should have, for example, 24 multiple 3 positions. But we didn't, fill these positions. Here, by using 3 for loops here, I filled this, these positions, and this is something tricky but very easy, and I have written this algorithm, and that works very well, and you can see this is the result here. But what is this algorithm? In general, this is for example 30, this is for example 30, and if you look at here, for example, for defining each triangles, we should say we need, for example, this point, 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 this point. So 2, for example, nodes from one line and 1 node from another line. I just do this technique for all of this triangle, but because I wanted to keep the level of this tutorial very simple, I don't want to speak about it right now. If you are very interested, you can just tell me. So after that, after filling the triangles and after filling the vertices, everything is ready. And so as if you can come back and in the make a mesh function, we have two things: make a procedural grid. This is make a procedural grid, and update mesh. So why we need to update mesh? Because each time when we change the position of the control point here, for example here, although the new point, the new position of these points is calculated, but the surface should be updated too. For this reason, we should say, hey, mesh.clear. It means that clear the mesh totally, and mesh.vertices is the vertices, which is calculated here, and mesh.triangles is triangles, and mesh.recalculate the normals. This is something that we usually use it, and for recalculation the normals is not necessary, but we usually use it. This is for the normals, and this is the advanced topic. I don't want to speak about it here. And after that, defining the new meshes here, after that, cleaning the mesh and filling the mesh, we just assign the mesh again to this game object. We just assign it again. But because everything is very fast, as I have told you, everything is in the update function, and everything is done many times in the second. You cannot feel the meshes clear. You cannot see the meshes repeated. For this reason, in the gaming, this is a very good tool for the gaming. When I change the positions, in fact the mesh will be clear and everything will be calculated, but you cannot see it because everything is very fast. Thank you very much, and for watching this video. And again, if you have any question, especially in this algorithm, you can ask me.